Hello and welcome to the second of my videos aimed at students who are considering taking A-level maths starting in September. My first video looked at partial fractions. This video looks at the Suvat equations. So let me just jump over to my prepared whiteboard. The Suvat equations are something you'll come across definitely if you take the applied maths or mechanics part of A-level maths. So, what do these letters stand for, and what equations link together the things that they stand for? That is the subject of this short film. I'm going to show you what the Suvat things stand for, what the equations are, and then I'm going to apply them to one situation at the end of the film. Right, let's get going. So, the Suvat equation is all about moving bodies. Sometimes you'll talk about particles, sometimes you'll talk about cars, lorries, anything that's moving. Okay, for this example I'll talk about car, just because that's what my picture is of. Okay, so if you're talking about how a car moves, there's certain things that you want to know about it. Like, for example, how long is it moving for? The time aspect. Okay, how long are we interested in? That's fairly self-explanatory. Okay, so the next question is, how fast is it going at the beginning and how fast is it going at the end? V stands for the initial velocity, U stands for the initial velocity, V stands for the final velocity. I'll always talk about velocity when I'm talking about Suvat. Speed means speed hasn't got a direction to it. So if I drive my car down the road at 30 miles an hour, and then turn left and keep on driving at 30 miles an hour, my speed is the same, but my velocity has changed because I'm moving in a different direction. But for most of these Suvat examples, we're talking about motion in one direction, but we're going to use the term velocity. Okay, so something else that we're interested in is distance. How far does this car travel in the seconds, the t seconds? Or the other thing I should mention is that for the Suvat equation, we will be sticking with meters and seconds. If you want to talk about kilometers or minutes or whatever, you need to convert into meters and seconds, because that's the numbers won't work out properly if you don't. Okay, so V equals UV D. Right, now I've got D here, but we're going to just change that to an S, because in the Suvat equations, distance is represented by the letter S. When you're mathematically modelling, you can actually use what letters you like. The Suvat situation is so well known that it's definitely you should stick to using SUV, the letters we're using in this video, SUVANT, because you might confuse people if you don't. Okay, so it's S for distance. And the last one is A for acceleration. Now, this is an important restriction when it comes to the equations that we're using or looking at in this video. These Suvat equations only work out if the acceleration is constant. If you're getting faster and faster at a faster and faster rate, you've got non-constant acceleration, and the Suvat equations don't apply. So A is a fifth of these things we're talking about in the Suvat equations. It's the acceleration, and it's basically the rate at which the speed is getting bigger or lower for a vehicle that's slowing down. Right, so, and that is actually measured in meters per second squared. Units do work out if you're doing the sum. Is the meters per second is the speed or the velocity, and then you divide that again by the time that the speed has been changing. That's where meters per second come in. Okay, so let's move on to the next screen, which is a summary of the 5 things we've been talking about. Initial velocity, final velocity, time, distance, and acceleration, which has to be constant for the Suvat equations to hold. And Suvat is just what we call them. You could call them arrays of letters in another order, but we'll call them the Suvat equations. Okay, so let's just start thinking about what these equations could be. Now, the first 2 equations I'm going to derive really from the real life situations. The third one I'm going to derive through a bit of manipulation, and the 4th and 5th ones I'm just going to give you for now, but you could get them from algebraic manipulation. And then it's always a good idea when we've seen the 5 for you to learn them as they are, because you'll be using them so often. And I'll talk about that a bit later when we come to use them, why it's so useful to actually know them by heart rather than having to derive them all the time. So the first one is actually derived from the definition of acceleration, which basically means the rate at which the velocity changes over the time. So you start, v is the velocity at the end, u is the velocity at the beginning, and we add on to that the acceleration multiplied by the time, because that means that the acceleration is a measure of how quickly things have gone quicker over time. So that kind of comes from the definition of acceleration. Now the next one we're going to look at is we'll draw a little graph for this one. I'm going to go over to my line drawing tool. I'm going to change the colour because I like changing colours every so often in these films. Okay, so 1, 2, let's draw a little line, and that's the time travelled, and that is velocity, and we'll draw yeah, that's what we want so far. Change colour again. Draw a line on, which is going to represent the rate at which a velocity changes over the period of time we're interested in. So that is basically the time. To my line drawing tool, it's easy to write letters then. T0, T1, and that we're saying there that T1 take away T0 equals T. The overall time of the experiment is between T0 and T1. And then on this axis we draw U as the initial velocity and V as the final velocity. And then that just shows, and because it's a straight line, the velocity is going up at a constant rate. We've got a constant acceleration. Okay, so what can we tell from this? Now, remember that the well-known from your GCSE course is that distance, in this case, we can call them distance S, equals velocity times time. In the GCSE course, you'll have seen D equals ST, and this is just using the letters we're using for Suvat equations to say the same thing. So your speed is your distance rather equals your velocity multiplied by the time. But here the velocity is changing, but because it's changing at a constant rate, we know that it gets to halfway between U and V, halfway between the two. So that there, it actually becomes that's actually the mean or the average speed if you'll reach halfway through the experiment. And actually, the average velocity is actually going to be useful for working out this distance. So what we have here, the average velocity, of course, is half of u and v added together. That more v-like, and then multiplying that by the time. So what we've done there is we've taken the average of the velocity, or the mean velocity, which is halfway between the initial and the final velocity, and we've multiplied that by the time. It's just another form of that equation down there. And that is the second Suvat equation, although when I see them listed, I often see this one, this is number 3. But hey, we can call it number 2 for now, because the second one we found. Those are the two that I think come out of just thinking about the situations and how they link up. The other equations, we need to do a little bit of algebraic manipulation, but you can get the other equations like this. What I'm going to do is I'm going to substitute in this equation v. So it's doing it by substitution. So I'm going to call it's again, s is on the left hand side, and then half of u plus, I'm going to replace v with what v equals in the first one. What I'm doing is I'm substituting the first one into the second one and seeing what we get. So that's u plus a t, and then we still have t outside the bracket from there. All I've done is replace v with u equal plus with there. That there is a replacement of v. Okay, so now we're just going to do a bit of manipulation, and we're going to say half of, there's 2 u's in there now, 2u plus a t, not changing that. Okay, and that's still multiplied by t. Now we're going to multiply what's inside the bracket with the things outside the bracket. We can do that in one go, really. So half times the 2, they cancel out, u times the t, so we're left with ut. That's half of 2u multiplied by t, and so that's ut. And then the other bit is half of a t squared, because there's a t inside the bracket and a t outside the bracket. So there we have, I've done a bit of working out, but there is a third of the Suvat equations, and it is ut plus half of at squared will give you the distance. That's not quite so intuitive, but by doing some substitution of the 2 equations that we've worked out through intuitive methods, we've got the third. Now I could do the same thing now of substituting, of using these equations and substituting bits for bits, and I'd get the other 2. I mean, I could have rearranged this one at the top to be u equals, substituting there, and then we end up with s equals vt minus half. You might want to just do that rearranging yourself. It's rearranging the formula in GCSE style. And you end up with that. And the last one, which I don't know, I always find fairly easy to remember, is v squared equals u squared. When I've been working on these a long time, I would find this one easy to remember, and I just had to go and look it up then. Again, that's, yeah, v squared equals u squared plus 2as. And that's the 5th one. So that's the 4th one. and that's the fifth one. They're often listed in a different order in textbooks, but that's the order in which I normally derive them. And 4 and 5 can be derived through substitution and rearranging the first three, but I'm cutting down the time in this video by not doing that in this video. Okay. So there we have 5 equations. Now they all have either S or V as a subject. And actually, you can rearrange any of these formulas to make anything a subject. To be honest, I don't always do that. I often plug the numbers in left and right and do the rearranging with numbers in. That's just my personal style. You could learn not just 5 Suvat equations, you could try learning 25 by making everything the subject. But I wouldn't recommend that. I'd recommend learning them in that form and then use your skills in rearranging formulae when you need to. Otherwise, I say do learn them. Rearranging formulas isn't too bad. Right. So we're now going to see how we can use this. These equations. I'll keep popping back those equations to check on them to find the answer to this question. So a car traveling at 10 meters a second accelerates at, and when I was doing this, I didn't put a 2 there. Important to get the unit right. Right, this. Put 2 up there. Right, like a bit of accuracy. So a car traveling at 10 meters a second accelerates at 6 meters per second squared for 5 seconds. How far does it travel? Now, what we've got here, we've been given the initial velocity, which is u. We've been given, well, u equals 10. We've been given the acceleration, which is 6. When I'm doing calculations, I often use the units, often sort out the units at the end. The time is 5, and we've been asked to work out the distance. So what we do here, we go back to the Suvat equations. Now, if you have a look at these Suvat equations, there, you'll notice that each of the 5 equations has one of the 5 terms missing. So this one's got S missing, that one's got A missing, and so on down the list. So normally you'll only be dealing with 4 things at once, and that'll help you choose which of the equations to use. In this situation, we're not using V. We've not been given V. We've not been asked to find out what V is. We have at the end, and we'll use a different one of the Suvat equations at the moment to find out V. But for the first part, and don't try doing this all in one go, do it step by step. The first part is not using V. So I'm looking for the equation that doesn't include V, which is this one, number 3. So that equation says, see what I'll do. I'm just going to copy that to the next page. So now we've got, and as it happens, the thing we're trying to find there, the distance S is the subject, so we don't have to do any complicated rearranging. Like I said earlier, if you could either, if you wanted to, if we were given S, U, and A, we were asked to find T, you could try rearrange this formula, but frankly, I think it's best to just plug the numbers in and see what you get, even when it's not the subject. Equals 10 multiplied by 5 plus half multiplied by 6 multiplied by 5 squared which equals 50 plus 3, which is half of 6, times 25, which is that's 75. So we've got 50 plus 75, which equals 125 meters. Now, some purists might think I should really write the units in every stage, but I must admit, when I'm doing a calculation, it's much easier to know that at the end the distance is in meters. So the units do all work out and cancel out, and they work out in meters. So there we go. This car, if it's traveling at 10 meters per second, accelerates at 6 meters per second for 5 seconds. Without knowing the final velocity, without knowing anything else, we can work out that it has traveled 125 meters. Right, let's now do the second part, which is what was its final velocity? Well, for that one, I'm going to use what I think is the easiest to remember, which is V equals U plus AT, and that is 10 multiplied by 6 times 5. 6 times 5 is 30, and that is a plus. It looks like a multiply, but it's a plus. And so the answer there is 40 meters per second. Now, we've now got all the numbers that we needed. Let me just put my units on these now. You can check now, and I'll be honest, before I started this recording, I did. Just check that the other 3 formula do hold, but they do because we all derived them from the others. And there we go. Now I could make the video longer by doing examples using the other 3 Suvat equations, but this video is long enough now, so I'm going to stop it. Later on, I'm going to do the occasional video or questions, and then we'll come back to these Suvat equations, and you'll see that they're very, very useful for several different problems types that you will come across in A-level mechanics, applied maths. Okay, thank you very much for watching this video. I'm going to make another one probably now, post it over the weekend, about just introducing calculus. So thank you very much for watching.